Okay, so I want to start off today's lesson with a very simple question, and that is, can you find any solutions to this equation? X squared equals -1. Is there a solution to this question? If you think there is a solution, you can shout it out what you think it is. But if you don't think there's a solution, you can do like emoji thumbs up or just say like a no or something. But again, do you guys think that there is some number X that you can find such that it squares to a -1? Usually you would think that the answer is no, right? Because if you try any number, you would have like, for example, 2 squared would equal 4, right? And sorry, 4. And if you have a -2 squared, the negative signs would cancel out. And so you would still end up getting 4. And so it's kind of hard to imagine how you would ever get a -1 or any negative number from a squared, right? So this is the question that led to the development of complex numbers. And the reason that mathematicians created them
Wait,
was
wait, wait,
because they were trying to find
wait,
a
wait.
solution to x
I
squared
think I
equals
just
negative
found a
1.
solution. I think I just found a solution to the over the x to the power of 2 x -1.
Really? Go ahead, share with us. Sorry?
Isn't it -1?
-1? We can try it. So
Wait, actually no, that would wait, never mind. That doesn't
if you
make
have
sense.
-1, that would give you
Yeah, because that would
x.
just give you +1.
Yeah, x. Yeah. And so like you would think that there isn't any solution to this equation. But again, this question led to the development of this thing called complex numbers. And again, it was because of curiosity regarding solutions that squared to a negative number. And at first, a lot of famous mathematicians ridiculed this. Like, they're like, this is such a dumb and silly idea. Why are you guys even thinking about this? And that includes Rene Descartes, which is this really famous mathematician. You can look him up after class. But this guy, Rene Descartes, he said that this number is imaginary. Like he was like joking, he was like scolding these guys. He was like, guys, the thing you're looking for is literally imaginary. And funny enough, that became a lasting name, and imaginary numbers is the name that we give to this new set of numbers that we're going to talk about today. Um, Jasper, today we're talking about complex numbers, and I'm just about to go into details, so just tag along. So this other really famous mathematician called Leonhard Euler, Euler is pronounced Euler. He provided the symbol I, and so you have the definition that -1, I mean I squared equals -1, right? And so this kind of like answers like the question above. Like it's kind of interesting because like the mathematicians are like, we can't find a solution. So instead, we're going to define a solution. So since we can't solve x squared equals -1, they're just going to define the solution as x equals I, where I squared equals -1. So in other words, you can also write it as I equals square root of a -1, right? So usually we take the square root of a number, it has to be positive. But in this case, the imaginary unit I is defined as the square, right? Because if you have a number, say something like I don't know, 4 plus 2i, actually, let me purple. So if you have a number like 2 plus 4i, this 2 here is called the real part, right? Um, and this part 4 here, this is called the imaginary part. And similarly, if you have a number just by itself, like 2 or like 3, that's called a real number. And if you just have something like 5i or like 6i or like negative 99i, these are all called imaginary. Oh no, I'm running out of space from the Zoom box thingy. Imaginary numbers. Right, I'm just not going to write real numbers here real quick. Real numbers. And collectively, real numbers and imaginary numbers are both known as complex numbers. So you can kind of think of complex numbers as the set or like collection of numbers that includes both real numbers and imaginary numbers. And yeah, so both real numbers are like the usual normal numbers that you've been working with all your life, like root 2 or 999 or negative 1,000. And imaginary numbers are literally just like your regular number, but multiplied by the imaginary unit I. So something like, negative 5i or negative 6i or 99i. But then a complex number, although it includes both, a complex number usually refers to like something like this, right? Something that includes both a real part and an imaginary part. But again, complex numbers also do include just real numbers and imaginary numbers. So does this quick introduction make sense before we move on? Is there anything about this that's kind of confusing? Because I know it could be confusing. Are there any questions about what I just went over? Going once? Going twice? Going 3 times? All right. I'm assuming we all understood that. So with that, I want to go to some basic arithmetic of complex numbers. And I want to start with this first question, which is find all values z such that z squared is z squared plus 144 equals 0. Um, so I'll give you guys like 30 seconds to a minute to kind of think about that. And then we'll see if anyone comes up with a solution. But again, find all values z such that z squared equals 144. And I'll give you a couple of seconds to think about that. That's right. You're trying to solve for z. So it's like your regular like equation where you're trying to solve for a variable. Except in this case, it may or may not include imaginary numbers, since this is what we're talking about today. Exactly, Jasper. That's the point. That's where the imaginary unit I comes in. Give you guys a couple more seconds, see if anyone can solve it. It's okay if you don't, because this is like a pretty complex. Yes, someone just found the answer. Yeah. So yes, Jasper, the answer would be something like negative 12i. But here's how I would solve this question, okay? So you would start by, again, by isolating the variable. If you've taken like a middle school, when do they teach this? Like 7th grade? That's when they teach you how to solve like basic equations. Right? You want to start by isolating the variable, right? So you get your zoom in a bit. Get your z squared equals negative 144. right? Because you subtract 144 from both sides, and then you want to take the square root of that, right? Right. But then, oh wait, sorry, because when you take a square root, it does have to be plus or minus. Now, if the inside were just 144, right, and there was no negative sign, then the answer would just be 12, right? Z would be equal to plus or minus 12. But the problem is, in this case, there is a negative sign, right? But if we go back to the definition of what a complex number is, you see that I squared is equal to -1, right? And I is defined as the square root of -1. And so that means you can like factor out this negative, you can factor out the square root of -1 and just tack that I at the end of 12, right? And if you want to double check this, you can, right? So you can go back and square 12i, right? And you would get 144 times I squared, which again is just -1, and you would get -144, which was the answer that we were looking for. So again, yes, this is the answer. Are there any questions about this? Does this make sense? And similarly, you can also check -12i, right? So if you square this, you would get 144, right? Because -12 squared is 144. The negative sign disappears. Times I squared, but again, that's just 144 times -1, which should give you -144. Again, does that make sense? Are there any questions about this? Going once? Going twice? Going 3 times? No? Okay. All right, let's try another example, or in fact, let's try 5 examples, because I want to go over the basic arithmetic involving complex numbers. And for now, basic means addition, subtraction, and multiplication. And so why don't you guys, okay, you know what? Here, I'll just explain how to solve it because you guys don't necessarily know how complex number addition works. But basically, when you have two complex numbers, you add the parts separately, right? So, in fact, yeah, I'm gonna go over this and then let you guys solve it. So if you have something like a plus bi plus c plus di, which is, right, two complex numbers, how you would add them is you would break apart the parentheses, right? You would have a plus bi plus c plus di. You would group the same parts together, right? You would group the real parts and the imaginary parts together. Well, in fact, you let them know that's too much of a chore. You would put A and C together, right? Because they're both real parts. And you would put the BI plus the DI together, right? Because they're both imaginary parts. And so what you would end up getting was A plus C plus B plus DI, right? And then A plus C would end up being a real number, and B plus D was also end up being a real number. So you have a complex part plus, sorry, you have a real part plus an imaginary part, giving you a complex number, giving a complex sum. No, it's not solved. I just give you like a general, I guess, formula or rule for how to add complex numbers, but these are with specific numbers. So you have to do them yourself. But this is how addition and subtraction works, right? If it's subtraction, it's the same thing, right? If I just replace this with a negative sign, everything would be the same, except that the sign would change. And so you would have A minus C plus B minus D instead of A plus C plus B plus D. But again, you just group the same parts together and just add and subtract them, right? Um, Multiplication is slightly trickier. I'm gonna do this below down here, right? Multiplication is slightly trickier, but it's really just expanding the terms. It's basically like if you guys ever worked with quadratics, it's basically like expanding a FOIL. You would have, for example, if you have a plus bi times c plus di. I'm zooming in a bit. My handwriting is kind of getting bad. You would simply have this right here. I'm gonna draw this in like different colors so you guys see it. So you would multiply these two terms together. You would multiply these two terms together. You would multiply, sorry, these two terms together. And finally, you would multiply these two terms together. So you just multiply them together and just add them up, right? It's really just the distributive property, right? So you get a times c. Why is it this color? You get a times c plus a times di, right? That's a bad I. Di plus bi times c plus bi times di. But then you can like rearrange it, right? You have AC plus ADI. Sorry, I missed the A there. AC plus ADI plus BCI plus BDI squared, right? But then this BDI squared really becomes minus BD, right? Because again, I squared is -1, right? This is equal to -1. And so you again, this is just like an addition problem, right? You group the real parts together, AC minus BD. Again, BD is real because I squared is equal to -1, so it just becomes a negative sign. And you add that to ADI plus BCI, and you can again factor out the I. And this would give you a complex product. And so this is how you would do multiplication with complex numbers. And so now that I kind of explained how you do arithmetic with complex numbers, why don't you guys give a shot, right? So let W equal 6 minus 3i, X equals -2 plus 5i, Y equals 2 minus I, and Z equals 1 plus 3i. And I want you to compute X plus Y plus Z. This should be fairly simple, right? The formula is right on there on the board. So I'll give you guys like 30 seconds to a minute. And hopefully you guys can solve this question. When you're done, feel free to either type it. And actually, when you're done, don't type it yet because I don't want to spoil it for other people. But when you're done, just like type in the chat that you're done. Okay? Go ahead and try it. He says, I am losing brain cells. Losing brain cells is how you gain more brain cells. Yes, Jasper, that's right. Yeah, sorry, my handwriting is like not perfect because I'm writing with a finger on a computer screen. But yeah, W equals 6 minus 3i. X is -2 plus 5i. Y is 2 minus I. Z is 1 plus 3i, not 31. And I want you to add x plus y plus z. Yep. I don't know if any of you are from like the Etowanda school district, but and I'm not sure if you guys are still taking these iReady placement tests, but when I used to be in Big Creek Intermediate, I had to take these iReady tests all the
Oh,
time.
I ready. Yeah, that's
And
I don't like I
there
ready
would
ones.
always be one or two questions about complex numbers. Wait, sorry, what was that?
I just said I don't like I ready whatsoever. I feel like it's just dumb. I mean, I guess I understand why the school wants to know where your level is at, but still, it's just dumb that they make you take this incredibly long test just to put you in a special like class in which they could easily find out by looking at your like grades or something.
No, yeah, I definitely agree with that. Yeah, I used to hate iReady tests too, because it's like
But
5 hours. Especially the reading test. That's tough. Right?
I
The reading test where they give you like passages.
yeah, I don't like those whatsoever. Those took me forever to get done.
Yeah.
Those are
Yeah,
also
but back to complex numbers. Did any of you solve this question?
I'm still working on it.
Was anyone able to solve this question? That's okay. Take your time. Are we almost there? I do want to go on to some other questions. Okay, I think I'm going to go ahead and start because I do have some other stuff prepared for you guys. But I think, if you couldn't solve this question, I think I'll go through the solution and you'll see. Um, you'll get a better idea of how this works. That's funny. Okay, let's do this. So for this question, it's fairly straightforward, right? You just really just plug in the solution. You want to do x plus y plus z, right? And shoot, okay, I'm gonna zoom in a bit. You want to do x plus y plus z, and you know that x is -2 plus 5i. You know that y is 2 minus i.
2x minus
And
I
finally, you also know that z is 1 plus 3i,
2i.
right? And so Again, complex number arithmetic works by grouping similar terms, just like any other algebraic equations you'll ever work with. And, and so you would have -2 plus 2 plus 1 plus 5i minus I plus 3i. And this should give you 1 plus 7i. Was this what people got? Yes, no, maybe so? Yes. That's right, Jasper. The negative sign still cancels. That's right. All right, nice. Let's try part B, shall we? Actually, you know what? For now, skip part B because it might be a little complicated. So why don't you guys try part C first, okay? Go ahead and try part C. And again, I'll give you guys like 30, no, I'll give you like 1 to 2 minutes. Oh, you know what? Okay, Jasper was doing part B. Yeah, why don't we do part C first, and then we'll go to part B because part B is like multiplying three terms together. I think it might be a bit more complicated. So let's work on part C so that you know kind of build up to part B. But good job, Jasper. You're doing great. You're getting it. What's WI? Oh no, no, sorry. That's actually a WZ. Yeah, I'm gonna type into the chat. It's WZ minus W minus Z. I know it's a little weird, but it doesn't have a dot, so as well as again to teach us some more line stuff. Sure. When did I don't remember using Desmos to teach line stuff. And I'm not sure that Desmos can graph complex numbers, but really what did I teach on Desmos? I forget. What were we
It was
talking
like
about on Desmos?
complex. It was like complex things. Like it was like complex making like lines and like curving lines and that sort of stuff.
I think that might have been another teacher. But sure, if we have time, I can go over some line stuff. But is everyone almost there with these questions with part C? Or do we need like 1 or 2 more minutes? That's okay. It's a tough question. Okay, I think I'm going to go ahead and start unless anyone has any strong objections to not starting for a couple more minutes. Okay. So Part B, right? Part B is find, sorry, no, not part B. Part C. Part C is find WZ minus 2W minus Z, right? W minus 2W minus Z, where, okay, this is actually not good because the 2 is looking like the Z. Okay, I'm gonna write Z in cursive like this so that we don't confuse these two, right? This is the cursive for Z. So WZ minus 2W minus Z. And from the thing, we know that W is equal to 6 minus 3i, Z is 1 plus 3i. Okay, so you plug these in, you get 6, zoom in a bit. You get 6 minus 3i times 1 plus 3i minus 2 times 6 minus 3i minus 1 plus 3i. Did I plug that in right? I think so. 1 plus 3i, right? And this is the first, this is a multiplication question, right? So you expand it, you have 6 plus 18i, right? That's from 6 is from 6 times 1 minus 18. Sorry, why is it minus? That's not right. It should be plus 18i, right? Because 6 times 3i. And then you have the minus 3i, right? That's the minus 3i times 1. And you have the minus 9i squared, right? And then on this side, you have minus 12 plus 3i, right? The two negatives cancel. You have the minus 1 minus 3i. So right away, these two cancel, right? That's kind of nice. Actually, no. Sorry, guys. This is not right at all. This is plus 6i, right? Because it's 2 times 3i. It's plus 6i. And then minus 1 minus 3i. I was like, I don't remember it being that easy and just canceling. But actually, no, yeah, it still does cancel. You can do this. You can minus 3i here, minus 3i here. That adds up to minus 6i. So you can cancel that. But to continue, you have 6 plus 18i plus 1, right? And plus 9, right? Because I'm approaching the limits of elements on this page. What? That's not good. Okay. Right, because I squared is -1, right? And so you have -9 times -1, that gives you a positive 9. And so you do that, and you still got the minus 12, minus 1, that's a minus 13. And this should add up to what? 15 minus 13, so 2 plus 18i. Did anyone get this? Are there any questions about this? Going once? Yeah, it is a lot of work. Yeah, I know. But like this is like when you first start working with complex numbers, right? Because like once you get used to it, you would not show this many steps, right? Here, let me show you how I would solve it as someone who's worked with complex numbers for a bit, right? So first of all, I would even write the step out. I would just refer to the problem. But I would just go straight off the bat and I would just say, okay, this is equal to, I'm gonna do a line here. Okay, this is equal to 6 plus 18i minus 3i, right? So that's just plus 15i. Oh my God, I hate using a finger. Plus 15i, right? And then you got the minus 9 squared, that's just plus 9. And you got at the minus 12 plus 6i, right? Minus 12 plus 6i. And finally, you got the minus 1 minus 3i, right? And then you immediately just say, okay, real part, 6 plus 9 minus 12 minus 1. That's 15 minus 13. That gives you 2. And then you got the 59 plus 6i minus 3i, that's just 15 plus 3, and that gives you 18i, right? So like once you get familiar, it's just 2 steps, right? But here I'm writing a lot of steps just because, oh my God, there's no way. Um, right, because you have the right, I'm just writing out all of the steps here because you guys aren't that familiar with complex number yet, and I'm just trying to show like what would the basic thinking process be. But once you get familiar with it, this whole thing is really just 2 steps, right? So um does anyone still need this? Because I'm going to erase it because Canva is like complaining to me about having too many elements on one page. No? Does anyone want this? Are there any questions about what we just went through? No? Okay. Yeah, I'm going to go ahead and erase this thing because it's not fitting. Actually, I don't really want to erase this. It's kind of tough. Hmm. Also, why is it view only? Sorry, guys, I'm having like technical difficulties. Hmm. This is really weird. Okay, never mind. I guess I'll use annotations instead. Okay, so we'll continue this using Zoom annotations, but let's now go on to part B, shall we? I'll give you guys again like 2 to 3 minutes to solve this because this one is a bit more harder. And yeah, go ahead and give it a try. I'm going to type this into the chat because I want to use these minutes to kind of like see if I can fix this. But you want to evaluate x times y times z, where x equals -2 plus 5i, y equals 2 minus I, and z equals 1 plus 3i. Okay, so go ahead and give that a try. It's in the chat, and I'll give you guys like 2 more minutes. Okay, let's see if I can fix this. I fixed it by erasing all of the other parts. All right. Do you guys still need a couple more minutes, or are we kind of getting how this works? Okay. I am going to go ahead and give the solution because I'm not sure how much progress we're making here. So this is really a two-part multiplication question, right? Because unless you're super good at math, you would not multiply all of these together. And I am not super good at math, so I'm not going to do that either. And instead, I am going to multiply these separately. So to calculate x times, why is my pen so thick? That's better. Okay, so to calculate x times y times z, I would start by doing x times y times z, right? So this is a basic multiplication question, right? So you got the what? You got the minus 2 plus 5i, and you've got the 2 minus I, right? Got the 2 minus I, and you have z. I'm going to do this too first, right? So I'm going to kind of skip a couple steps just because I want to see if you guys are kind of getting it. So, right, this would be negative 4 plus 2i plus 10i plus 5, right? Because 5i times negative I is negative 5i squared, which is negative 5 times negative 1, so that's plus 5, right? That's times z. And if you reorder this addition question, you have 1 plus 12i, right? That's the first product. And then you multiply by z, which is 1 plus 3i. So you would have, again, simple multiplication question. You have 1 plus 3i plus 12i minus 36, right? Because 12i times 3i is 36i squared, which is just 36 times negative 1. And this should give you negative 35 plus 15i. And that should be your answer. I'm not sure how many of you got that. Did any of you get this answer? Are there any questions about what I just went through? Once, going twice, going 3 times. Okay, nice. I am going to go ahead and erase this just so that Canvas doesn't say I'm running out of elements. And I am going to go ahead and move on to the next part. So I'm going to follow this arrow, and it says, oh, wait, no, there should be a different arrow here. And we're going to find patterns of I. So first of all, I want you to do me a favor, and I want you to evaluate I to the 7th, right? What is I to the 7th? In other words, what answer do you get when you multiply I by itself for 7 times? I'll give you a couple seconds to think about that, but I don't want to dwell on it for too long because we'll have 10 minutes left. So go ahead and think about that, and if you have an answer, just shout it out. Wow, Jasper, that's very impressive. That's right. That's exactly right. Was that a guess or did you actually solve that? Oh, that's exactly correct. It's negative I. Here's how you would solve that. I don't know if Jasper just guessed that or if he solved it, but either way, it's pretty impressive because that's the right answer. But the way you solve this is you look for a pattern, right? So I will just write it out. So why is my pen always so thick? I swear to God. I do a transparent. I'm gonna do a three. There you go. Okay, so I would start off by just writing powers of I, right? So I to the first power is equal to just I, right? Right? It's just I by itself. I to the second power would be -1, right? Because that's how I squared is defined, right? I squared equals -1. I to the third power is basically I squared times I, right? I to the first power. So that's really just -1 times I, so it's -I. And I4 is equal to I squared times I squared, right? But that's really just -1 times -1, so it's equal to 1, right? So that means for every 4 powers of I, the pattern repeats, right? Because if I4 equals 1, that means I5 would simply be I4 times I to the 1, right? But then I to the fourth power is 1, right? It's just 1. It doesn't do anything. So that means I to the fifth is really just equal to I. Um, and so this will mean that I to the sixth power is equal to I to the fourth times I to the second power. And so it would be I to the second power, which is -1, right? And then finally, you have I to the seventh power, which would simply just be equal to I to the third power. And that would be equal to -I, right? So the answer is -I, and Jasper, you are absolutely correct. So in this case, you can kind of like cheat a little. You can just write it all out. But no, knowing this pattern is really important because I'm going to give you this question. Evaluate I to the 20,000 to the 2007 power. And it looks like a negative sign. And we write that. But go ahead and try that out. What is I to the 2007th power? Yep, I know. That's like you have to know the pattern. But it should be fairly simple. It's the same idea. It's the exact same idea. It's a guess. I'm not going to count it. I'm not saying it's wrong. I'm just saying like if it's a guess, I don't really want to, you know. Maybe. That's more or less the idea. Yep. Okay, let's tackle this. Or do you guys want like one more minute to think about it? Okay, let's go ahead and solve this, shall we? So here's how I would solve it. Again, right? I4 equals 1. We have already established that. And again, that's because this is equal to I squared times I squared equals -1 times -1 equals 1. Right? So I to the fourth power equals 1. But doesn't that mean that I to the eighth power also equals 1, right? Because that's just I4 times I4, right? So that's also negative. 1. I mean, that's also just 1. Doesn't that mean I to the 12th power also equal 1, right? Because that's just I to the 8th power times I, no, I'm not going to write that, times I to the 4th power, right? Similarly, I to the 16th equals I to the 20th equals I to the 24th all the way to I to the 2004 equals 1, right? All multiples of 4 gives you 1. That means I to the 2007 is really just equal to I to the 2004 times I to the third. And so it's really just I to the third, which is negative I. So yes, Jasper, you ended up, oh my goodness, I swear to God. I can't write anymore, but again, Jasper, you were correct. And the answer is indeed negative I. So yeah, Canva is not cooperating very well. And yeah, but I'm going to stop around here. I did prepare a lot more stuff. I'm gonna show you guys real quick, right? Right, so we started here, right? We started here and we talked about the basic arithmetic of complex numbers, right? We did basic addition, basic subtraction, basic multiplication. And we also kind of explored like the patterns of I and what happens when you raise I to different powers. And so, yeah, I do think so, but I also think that it's important to get a good understanding of this basic arithmetic because this is really just the fundamentals of complex numbers, right? This is really all there is. And if you get this, everything else will be a lot easier. If you don't get this, nothing will make sense. So next class, we're going to review this, right? And then we'll kind of go over the division involving complex numbers, and we'll also go over some applications to problems. But with that, this is all I've got for you today, and I'll see you next week. Goodbye.